Alright everyone, today I'm going to be teaching you how to find the equation of a circle whenever you can't really tell what the radius is here. Okay, so looking in this problem, notice that this length here, we really can't tell what it is. A lot of people would like to say that this goes through 1, 2, 3 boxes, but the length of this is actually not 3. So what we need to do is figure out how to find the length of the radius. We're already given the center of our circle, which remember that's going to be a big key in finding the equation of the circle. So again, we're going to need some formulas here. What we're going to be doing is figuring out the distance between this point and this point. So we will be using the distance formula. Okay, you guys use that, I think, in Math 1 and 2. But again, I don't expect that you should remember everything from Math 1 and 2. So here is the distance formula and the equation of a circle. Okay, so the distance formula. All you need to do is take one of the x-coordinates and subtract it from the other. And you're going to square that. And then you're going to do the same thing with the y-coordinates, and then you just take the square root of everything. So if I'm going to find the distance between these 2 points, we're using these 2 coordinates, -5, -6, and 2, -2, -4. Okay, so this first one we're going to call x1, y1, and this one we're going to call x2, y2. Okay, it doesn't actually matter which ones you call which, so I could call these x2 and y2 and x1 and y1, but you just need to make sure that they're both labeled the same thing. So these should both have a 1, these should both have a 2. Okay, so that's really the most important part here. All right, now we're going to figure out the distance between these two. So d equals the square root, and we're going to do x2 minus x1. Okay, so we're going to do -2 minus -5. Okay, that's going to be an important part here. We're subtracting -5, which looking forward, that's going to change to a plus. Okay, squared, and then plus, we're going to do our y2 minus y1. So we're going to do -4 minus, and our y1 is -6. So we're going to have to subtract -6. This is all up under the square root. Okay, now we can do some simplifying here. And if you wanted to, you could really just type all this into your calculator and then just press enter. But we're just going to be a little bit more precise here. So still under the square root. All right, again, these two negatives are going to change to a plus. So it's going to be -2 plus 5 squared plus, and this is going to change to a plus as well. It's going to be -4 plus 6 squared. Okay, if you don't need all these steps, then don't write all these steps. And then we're just going to keep on going. So the square root of -2 plus 5 is going to be 3. So this is going to be 3 squared plus, and then this is going to give you 2 squared. All right. 3 squared, if you didn't know what it was, you could just type it into the calculator, but it will give you 9. And then 2 squared is 4. And 9 plus 4 would give you 13. So our radius here is going to be the square root of 13. Okay, that's going to be your radius. Okay, now that we know our radius and we have our center HK, which is -5, -6, we can just plug it straight into our circle formula. Okay, so now that we have our radius, we're just going to plug this straight in. So we're going to have x, and then we're going to use the opposite of this first point here. So see how this is -5? This is now going to change to x plus 5 squared. So using this formula up here, then plus y, and then opposite of this. So this was -6, now it's going to become +6. So y plus 6 squared. And then this is the kind of weird part. See how this is inside of a square root? Usually we would write this as the square root of 13 squared because r is squared. So now this is just going to equal 13 because whenever you square this, you're just going to get regular 13. Okay, so this is your answer here. This is the equation of the circle. All right. So again, the reason we did this is because you can't actually tell what this distance is here. So we did not know what r was. So you have to use the distance formula to figure out r, and then you can just plug that straight into your equation. Don't forget that the h and the k values are going to switch whenever you're here. So this was -5, became +5. It was -6, now it's +6. Okay, I'm going to show you another example, and this one is going to be using slightly a different technique. Okay, so example number 2, same type of problem. So determine the equation of the circle. Okay, again, it's not quite clear what this radius is here because it doesn't go through like a solid amount of boxes. So we're going to have to use the distance formula, but here we're actually going to use the Pythagorean theorem. Okay, the Pythagorean theorem. Okay, the Pythagorean theorem goes a squared plus b squared equals c squared, where this c over here is your hypotenuse, so your longest side. Okay, so we're going to be using the Pythagorean theorem. All right, what we're going to do is, since we're trying to find this here, and we have our grid marks, we're actually going to create a triangle. Okay, we're going to create a triangle. So the triangle that we're going to create is this here. Okay, this triangle inside. Okay, now that we have this, I'm just drawing it alongside the boxes. This is a right angle, and we're just going to use the Pythagorean theorem to solve this. So what I'm going to do here is I'm going to kind of take this triangle out and show you what it looks like outside of context. So it was over 4, up 1. So this is the triangle that we're working with. We're trying to find our r value, and we know that this was 1 unit and this was 4 units. So now we're going to use the Pythagorean theorem here. Okay, so we're going to do a squared plus b squared equals c squared. Again, c is going to be your longest side, which happens to be r here. So we're going to do 4 squared plus 1 squared equals r squared. 4 squared is just going to give you 16. 1 squared gives you 1. And this is still equal to r squared. 16 plus 1 would give you 17. And we're going to have this equal to r squared. And then to get r by itself, we're simply just going to take the square root of both sides. Okay, so we're going to do the square root of 17 equals r. The reason we don't do plus or minus square root here is because we're looking at distance, and you could not have a negative distance. Okay, so this is going to be our r that we're going to use here. Now that we have the r, we're just going to use this in our circle equation using the h and k values here. Okay, so now our circle equation should be pretty easy. It always starts with x, opposite of this, so plus 3 squared, and then the opposite of this one, so y plus 2 squared. And then this is going to equal this bad boy squared. But since this is inside the square root, whenever you square it, it actually just comes out of the square root because those are opposite operations. So this is your formula for this equation of a circle. Okay, and I'm going to show you how we could have done this with problem number 1. So this is how we did with problem number 2. We just said, okay, this is over 4 up 1. So if I do a squared plus b squared equals c squared, then you can do the Pythagorean theorem here and figure out r. So if I were to do it for problem number 1, okay, you could see that this triangle would be here. Okay, this has 3, this is 2, so it'd be 3, 2, and you're trying to find r. Okay, this is our r value. Notice that you would have 3 squared plus 2 squared equals r squared. Okay, you would have 3 squared plus 2 squared equals r squared. All right. Then, if I was going to get r by itself, you would take the square root of both sides. So, what we're going to do first here is we're going to make this 9 plus 4 equals r squared. 9 plus 4 is 13. So we're going to have 13 equals r squared, which means that r equals the square root of 13. And notice that this actually gives you the same radius that we found earlier. So this is 2 different ways that you could do the problem. Whichever way you feel more comfortable with, I would like for you to use that way. Okay. And just remember that you're squaring the radius on the end. That will be the most commonly missed mistake. So just keep in mind the distance formula and the circle formula whenever you work out these problems. And they will look very similar on Delta Math, I will show you. So going back to Delta Math, this is actually the equation that I just worked for you. Okay, so this is the second example, determine the center and radius. So we found the equation to be, if it will let me go, x plus 3 squared plus y plus 2 squared, and this equals 17. Okay, equals 17. Okay, and we got a nice green check mark. So this is the type of problems that you're going to be doing today. Hopefully you don't find them that challenging, and like I said, Delta Math will explain to you how we got the solution. So this is exactly what I did on the paper. It was over 4 up 1. So use the Pythagorean theorem, get the square root of 17, and then you get this formula. Okay, so Delta Math can really help you out with these things. I hope that you enjoyed this video. I hope it made sense. If it didn't make sense, please feel free to drop some questions in the discussion forum, or you can message me on Remind and I'll be happy to help you out. Thank you so much.